Okay, our next section is 6.3. We're going to talk about medians and altitudes. And hi, do you see my face? Kind of crazy. There's Mrs. Ruland. Mrs. Ruland, say hi. So remember we said we're making our videos a little bit different and they want us to have our faces in it. So weirdo, here's my face. Haha, do you see me? Anyways, we are going to work on medians and altitudes of triangles. So the first part that we're going to take a look at is what is a median. So we've talked about median in the past in your math. Median is kind of like in the middle, like the middle of a road. So how would we describe kind of like the median or the middle of a triangle? Well, the way that we do that is that the median is a segment from a vertex to the midpoint of the other side. And again, I know this is a midpoint because I can see that these two pieces are not straight here, meaning that these two pieces are equal. They are the same. So this right here is a median. It's considered a median of a triangle. The next part is our first theorem today, and it's theorem 6.7. It's called the centroid theorem. It sounds like a robot or something, but it is not. It is the centroid, and what the centroid of a triangle is the point where the three medians meet. So we just talked about what a median is. It's when I take a vertex and I go all the way across to the median of the other side, meaning that this side and this side are the same, right? So I'm going to do that on all three of the sides and from the vertices. And the point at which this meets in here, they're calling that P. That's called the centroid. And what's special about the centroid is that these pieces create this special fraction. So I know that this here is 2/3 of the whole thing. So it means that this little piece is 1/3 and this piece right here is longer. It is 2/3 to make up the whole piece right here. And that's true for each of these pieces. Like this one, this longer piece here is 2/3, and this would be 1/3 of that. And of course, we can use that to solve different equations. Okay, so we're going to look at an example of a centroid. And a centroid, again, is this spot where the medians meet. So you can see the given that point Q is the centroid. And what we're trying to find is QW and SW. So you can see it's this piece right here, SW and QW. And Q, remember, is the centroid, which tells us some special things. Remember, it tells us that this piece right here is 2/3 compared to this piece, which is 1/3 of that whole piece, SW. Now, it's really important when you're taking notes, please make sure that you draw this whole piece. I know you're going to have to like pause me and start again and whatever. That's totally okay. You've got to get the picture of it. Otherwise, it's not really something that makes a lot of sense. So make sure that you're using the pause button and rewinding me if you haven't had all the pictures or time to do the pictures. So in this example, again, I just took this little guy right here and I just kind of drew him over here. So I'm looking at the segment SW all the way across, this SW right here. And again, they told me that SQ is 8. That was given. And they told me, remember, that Q is a centroid. So if Q is a centroid, it means that this 8 is 2/3 of what the whole piece is. Okay? So if this is 2/3, a third and a third, and if 2/3 is 8, then I know it's like, if I split this up into thirds, this would be 4, 4, and 4, right? To get 3/3. So if 8 is 2/3, then 4 would be 1/3. And that answer is actually part of the question. They asked for QW, which is this little piece here, which I know is 4. And then they asked for SW, which is the entire thing, to add them up to total 12. Okay, the next example of this using this centroid, this is a little bit more complicated, so stick with me on this. Be sure to use your pause button, write down the 3 points, and the very first step that we're going to do is graph. So take a minute and make sure you get this little guy graph. So just these 3 pieces, and then we're going to talk about what the rest of my picture is. So just make yourself a little picture with those 3 vertices, and then we'll talk about what they mean. So the second thing we're going to do is find the midpoint of a side. And I just chose this side here. Why? No really rhyme or reason. That's the one I picked. So I decided that side. And again, I need to find its midpoint. So I took G and H, those were this made up this side that I was looking at, and I found the midpoint. So I used the formula. Remember, I wrote all of this out so you could write as much or as little as you need because you know how to find the midpoint. I add the x's, divide by 2, and I add the y's and divide by 2. And I get the point 5, 5. So that's what you can see up in my picture. I put a little arrow at 5, 5, or pointing to 5, 5, because that's the midpoint. So again, I've just created that little midpoint right there on my GH. Okay, so now the next thing that I need to do is right here. So this little guy, I need to find what the centroid is, and in order to find the centroid, I need to know the distance from here to here, because then I can take 2/3 of it and find out where this little centroid guide is supposed to be. Okay, so I took, here it is, the distance from 5, 5, so that was my midpoint, to F. And I can see that it's just straight across from each other. Like this was at 5, 5, and this was at 2, 5. They're just right straight across from each other. So I just took 5 minus 2, and I got 3. So if I know that the whole thing is 3, I need to take 2/3 of that to find out how long or where this centroid is going to be. So I took 2/3 of 3, and I got 2. So this little guy is 2 pieces long, and then that one would be 1 piece long. So that's how I was able to figure out where that centroid was located. So if I go back up to my picture here, you'll be able to see that this is 2 places away and this is 1 place away. And I know my picture is not the best, but that is how we got our 4, 5 for our centroid. Or do I have that backwards? This might be 2 and 1, isn't it? My bad, I think I switched them around. So our centroid is 4, 5. And the next piece today is the altitude. And the altitude, remember, like if they talk about the altitude of a plane, it's talking about the height. So the altitude of a triangle. So I can see I've got this acute triangle here, and if I draw an altitude is going to be the segment from the vertex to the opposite side. And I'm going to have this little right angle here, because remember, like if you go to the doctor's office, they say stand up straight, right? If I'm trying to get your height, I can't be like leaning over. I wouldn't be able to get an accurate height. So I need to be straight up and down. In an obtuse triangle, you can see that I actually had to draw my altitude outside of the triangle because it wouldn't have fit right here. If I just tried to draw like a perpendicular, I need to know from the very top to this very bottom here. So I had to kind of come out with my altitude. So what we're going to do with our altitude is find the orthocenter. The orthocenter is where the 3 altitudes meet this time, okay? So I have to draw my 3 altitudes. So again, how tall is from A to this side here? How tall is B to here? How tall is this? So again, I'm going to have these perpendicular pieces right here. And this little guy, where they meet, is going to be my orthocenter. Now this little bubble over here is going to be important for when we solve these in our homework assignment. It's a little tricky. It's a reminder that the slope of perpendicular lines is the opposite reciprocal. And I kind of just did like a light highlight right here so you could see. If I know what the slope of this line is, I could find the slope of this line to know what that perpendicular line should be, like right here. So I'm going to need to know slope and a reminder of that for the For our orthocenter, we kind of take a look at some acute triangles, and I'm going to see that the orthocenter meets inside the triangle. If I have a right triangle, that orthocenter, you can see from this vertex to here, and this vertex to here, and here, the orthocenter is actually on the triangle. And then again, with that obtuse triangle, they're a little bit weird. They're a little bit strange to draw. But if I'm going to draw this perpendicular piece and here, the orthocenter actually meets outside of the triangle. Now this last piece the book does, and you don't have to put it in your notes. It's really just up to you because we've already taken notes on all 4 of these. Sometimes though, it's nice to have something all in one spot, and then you can go back if you need to take a look at how to find it. But a review of what we've talked about so far. So the circumcenter is the center, and look at what's happening with all these pieces. Each of these is the same. Remember, they're equidistant from the vertices. Here, these are equidistant, the same, but they are also perpendicular. So that was something special about the incenter. Today we talked about the centroid, which are those medians. Remember the median from the vertice to the side, which creates these equal pieces, which means it's in the middle, makes it that median. And then we just talked about the orthocenter and what was special about that. So if this is something you want to do, you sure can, but you do not have to. This video today was so long and you did such a good job finishing up. I know you're going to take all of your notes. So bonus, special bonus for today. My favorite soda is Coke. Mrs. Rulin's favorite soda is Dr. Pepper or Mr. Pibb. What is your favorite soda? If you come and tell us, you will get a bonus.